Hello, welcome to this lesson of our study of differential equations. Okay, so in this lesson we'll go through another way of solving or another method of solving Fredholm's integral equation. Okay, it is still under the exact method, but here the kernel is degenerate. Okay, so if you have not subscribed to my channel, kindly subscribe to support the channel as well. Okay, thank you. All right, let's start. I suppose you solve the Fredholm's integral equation below, and it's giving us y of x equals x squared plus 2 times this integral, okay, where we have our limit to be 0 to 1 and our kernel to be 1 plus 3xt, this one. Okay, so this is degenerates. Our last discussion we talked about degenerate kernels. What a degenerate kernel is, we said that a degenerate kernel is a kernel, let's say k of xt, that can be written as, or that can be expressed as summation of some functions of x and t. Okay, so this can be written as x 1 plus 3xt. So if you pick our k1 of xt, that is the first kernel to be 1, then our second kernel k2 of xt will be equal to 3xt, right? So this is summation of some kernels, summation of two functions of t. This is indeed a function of x and t because x here is to the power 0 and t here is to the power 0 as well. I hope you get this. Okay, so let's continue. Okay, so with this, how are you going to solve this? Since it's a degenerate kernel, you go about using the same method we used in that just ended lesson, that is solving with a separable kernel. Okay, you have to expand the integral sign to get summation of separable kernels, or summation of integral equations with separable kernels. Okay, so this is what I mean that if you have, the question is y of x equals s squared plus 2 into integral from 0 to 1, okay, 1 plus 3xt y of t dt, then what you have to do is I have to expand this side. Okay, I have to multiply my y of t through, okay, and I'll have something like y of x is equal to s squared plus 2 integral of 0 to 1. Okay, if I multiply y of 2 by 1, I'll get y of t, then plus 3xt y of t, all dt, right? So since I have summation of some functions here, I can split the integral sign into 2 to get some summation of kernels. Okay, so this is what I wanted to say. 2 into the integral from 0 to 1 y of t dt plus the integral from 0 to 1 3xt y of t then dt. Okay, I hope you get what I'm trying to say. So if I multiply 2 throughout, I'll get something like this: y of x is equal to s squared plus 2 integral from 0 to 1 y of t dt, then plus 2 into integral from 0 to 1 3xt y of t dt. Okay, so this is what I have. Okay, so now what we can do is we can start seeing, or we see that this kernel has then turned to be a separable kernel. Okay, that I can separate 3x from t. Okay, I hope you can see this. So you apply the same method that we did for the first lesson we had. Okay, so y of x here is equal to, what do I have here? I have s squared plus 2 into integral from 0 to 1 y of t dt, then plus 2 times, I'm factoring 3x out from the other one, 0 to 1 ty of t dt. All right, so this is what I've gotten here. Now we said that since we are integrating with here, you can see that the function here is only t in terms of t, y of t. Here to have t multiplying a function of t, and the results will give me a function of t only, of which when I integrate with respect to t, and this integral is just a finite one or a definite integral, that is from 0 to 1, I will definitely get a constant, a number. Okay, when you say we get a constant, what we mean is just a number. Okay, so it means that y of x here will be equal to s squared, let me see, s squared plus 2. Then this will be a constant c1, let me call it that one. That, I mean, if I multiply 2 by 3x, I'll get 6x. Okay, plus 6x. Then let me write it to 6x. Then I call this constant as a c2 because the two constants wouldn't be the same. Okay, because I have a t multiplying something and I have y of t only, so here will be just c2 and this will be c1. So this is our solution. Okay, let's call it equation 1. What we have to do here is just go and find our c1 and c2, but we know that we are saying that c1 is equal to the definite integral y of t dt from 0 to 1. Okay, and our c2 is equal to the definite integral from 0 to 1 t y of t, okay, dt. Then you can see that if you put this c1 here and c2 back in this first equation, we'll get back our question. Okay, all right, so what you have to do is go and use our idea we have in y of x to find our y of t. Okay, so given, like we did for the last lesson, y of x is equal to s squared plus 2c1 plus 6x c2, right? So it means that if I ask you to find y of 2, okay, then it means that wherever you see x, you put in 2. So we get 2x plus 2c1 plus 6 times 2 c2. I hope you get this. So if I ask you y of 10, you put 10 in place of x. Okay, if I ask you y of z, that is z, you put z in place of the x component or the x part. Okay, so this simply means that I can evaluate my y of t using this idea or this function of y of x. So it means my y of t will simply be equal to putting t in place of x. So I have t squared plus 2c1 plus 6t c2. Okay, so therefore our c1, which is equal to integral from 0 to 1 y of t dt, can simply be equal to integral from 0 to 1 y of t is giving us t squared plus 2c1 plus 6c2. Then from what we have the t here, so we integrate everything, is 6t, right? 6t c2. Okay, so my c1 will simply be equal to just integrate this one, and I'll have integrate t squared with respect to t. I'll have 1 over 3 t cubed plus 2t c1, because 2c1 is just a constant, so I just have to integrate a constant. I'll get 2t c1, then plus 6t squared over 2. Okay, so 6t squared over 2c2, meaning that say divided by 2, I'll get was 3, so I'll have 3t squared. Okay, I hope you get this. So 3t squared like that. Then we simplify everything from 0 to 1. When I put the bar there, it means I'm simplifying everything. Okay, so let me have it that way. So when I put 1 in, what will happen is that I'll get c1 to be equal to, when I put 1 in, I'll have 1 over 3 plus 3c2, or let's say 2c1. Okay, 2c1. Okay, my pen is actually misbehaving. Oh gosh. Alright, so 2c1. Okay, then plus 3c2. Okay, so this is what I have for c1 when I put 1 in. But when you put 0 in, you get minus 0 plus 0 plus 0. Okay, so it means that putting 0 in is not necessary here. Okay, So this is what I've gotten for my C1. So if I bring this C1 here to the other side of the equation, okay, I'll get something like 0 is equal to 1 over 3. Then plus, when I bring C1 here, becomes 2. Let me write it, okay, 2C1 minus C1. Okay, bringing this C1 there, then plus 3C2. Meaning that this C1 will reduce by 1 and we'll get only one C1, that is C1 plus 3C2. Okay, it means if I take the 1 over 3 to the other side of the equation, we'll have something like C1 plus 3C2 being at the right side of the equation, and it will equal to negative 1 over 3 being at the left side of the equation, and then rearranging it can work like this. Okay, so I hope you can simplify and get an equation like this. So this is equation 2 of what we've gotten here in terms of C1 and C2. So we go ahead and do same for C2. C2 is giving us integral from 0 to 1 t y of t dt. So what you have to do is C2 is equal to integral from 0 to 1 t, then y of t gave us what? Okay, so y of t is actually equal to t squared plus 2c1 plus 6t squared c2. Or is it 6t c2? It's just 6t, right? Let me see. My y of t is equal to just 6t, not 6t squared. Okay, all right. 6t c2 dt, right? Let me write my dt well. This is what I have. So what other I have to do is just multiply t throughout and then start integrating. Okay, so c2 is equal to integral from 0 to 1 and multiply t throughout, you get t cubed plus 2t c1, then plus 6t squared c2, right? That is what I have right now here, and everything is what? The t, right? So what we can do here is just try to simplify or integrate. So I have c2 being equal to, and I integrate 1 t cube, I'll have what? 1 over 4 t to the power 4 plus 2 t squared over 2, right? But here the 2 over 2 goes, so we have only t squared c1. Okay, t squared c1 plus, when I integrate 6t squared, I'll have 6t cubed over 3, and that will give me 2t cubed c2. Okay, I hope this is okay. So I have 0 to 1 here. I'm simplifying everything from that, and c2 will just be equal to, putting 1 in, I'll have 1 over 4 plus c1 plus 2c2. When you put 0 in, you get 0. Okay, so bringing everything to the other side. Okay, let me do it straight, and I hope you understand. I'm bringing c2 to this side. Okay, I'm taking c2 from this side to this side, and I'll take 1 over 4 from this side to this side. Okay, so it means I'll get c1 at the right side. I'll get c1, okay, plus c2 is equal to, when I bring 1 over 4 to the other side of the equation, I'll get minus 1 over 4. Okay, I hope you get what I'm trying to say here. I hope that is okay. All right, so this is what I have here as the third equation. So the equation that has C1, both C1 and C2, is the third equation, this, and the second equation, that the first equation is for the main solution. Okay, so you are looking for C1 and C2, come and put them here, and then you have found our solution. Okay, all right, so let's go ahead and try to solve the two equations that contain C1 and C2 as using simultaneous equations. Okay, so C1 plus C2, was it 3? Yes, equals -1/3 as our equation 2, and our equation 3 was C1 plus C2 is equal to -1/4. Okay, so maybe you want to show us how you solve this equation, okay, mathematically. Then what you have to do is you state your formula here that using the Cramer's rule or Cramer's rule, the Cramer's rule, okay, Cramer's rule, or you can use method of substitution or method of how do you call it, elimination, okay, to solve this. So, but you can use your calculator to solve this as well. Okay, so we have this. If I write this in a metric form, I have 1, 3, 1, 1 here. Okay, then C1, C2 is equal to -1/3, -1/4. Okay, so using the Cramer's rule, what we'll say is that C1 will be equal to, let me come and write it at a different place. Okay, C1 will be equal to the determinant of, what you do is you replace the whole of this in the first row of this one. Okay, and that will be the determinant of that matrix. Okay, so I have determinant of -1/3. Okay, let me write it well for you. -1/3. Okay, or if you want, you can use a method of elimination if that will work fast for you. Okay, so -1/3. Wow, this is not working. -1/4. Then I write my steps I have here back. 3, 1. Determinant of this over the determinant of the whole matrix, and the whole matrix is 1, 3, 1, 1. Okay, and if you compute your determinant carefully, you get the top one to be -5, or is it -5? No, you get 5/12 or something like that. 5/12 over -2, and this will give me -5/24. That's my C1, and my C2 will be equal to the determinant again. But again, you place the this side or this side here at the second column. Okay, that will be the C2. Okay, so if it was a 3/3 matrix that we were solving, after that, then the C3 you place this to the last column. Okay, like that. So determinant of 1, 1 here. Now you place 1/3 here, 1/4 here, over determinant of the whole matrix, and that is -2. Okay, and this will give me 1/12. Okay, over -2, and this is equal to -1/12. Okay, so these are my C values, my C1 and C2. Or you can, like I said, you can actually use the method of elimination. You set C1 equals something. Okay, so here in this equation, what you could have done is, from equation 2 you can, or from equation 1 you can say that C1 is equal to -1/3 minus 3C2. Okay, then you come and put this here in this third equation. Okay, and then you get only an equation involving C2. Then you simplify for C2, then you come and put C2 value here to find C1. I hope this is okay. So if you think that one will work fast for you, just do that. Okay, so I have my C1. Let me write my solution back. Y of x is equal to x squared plus 2C1 plus 6x C2. Now my C1 is equal to -5/24, and my C2 is equal to -1/12. Or is it 24? 24, right? Let me go and check. Wow, this is negative 1/24. Okay, I made a mistake here. 24, -1/24 actually. So what you do is just put them back in it, and you have y of s, or y is equal to s squared plus 2 into negative 5 over 24 plus 6x into negative 1 over 24. Okay, so what will happen is just simplify them. 2 goes here 1, goes here 12, 6 goes here 1 and goes here 4. Okay, so you have y of x, or y, is equal to x squared minus 5 over 12, okay, then minus x over 4. Okay, so if you want to arrange it or rearrange this properly, you say y of x is equal to, from highest powers of x, okay, that is what you write it, x squared minus x over 4, or 1 over 4x if you want to write it that way, 1 over 4 times x, then minus 5 over 12. I hope this is okay. So this is a solution to the question, especially when you have degenerate kernels. Okay, I repeat it again, when you have degenerate kernels, then you have to split the kernel. Okay, thank you, and don't forget to subscribe to my channel if you have not subscribed yet. See you next time.